me now?
Yes, miss.
Yes,
And
ma'am.
that
And
took the
can you see the screen now?
yes, miss.
Yes, miss. Partial differentiation. Period.
Partial differentiation, right. I think there was a problem with that laptop. I don't know. I have taken another laptop. I have taken another laptop and I tried with this one. Anyway, we have lost sufficient time. So this is partial differentiation. We know that z equal to f of xy represents a surface in three-dimensional space, because you know, if you have the equation y equal to fx, it is in two dimension, and in two dimension y equal to fx represents a curve. And if you have the variables in three dimension x, y, z, the equation may be like this: z equal to f of x, y. It may be x equal to some function of y and z. It may be y equal to some function of x and z, etc. In all these cases, this type of equation represents the surface in space, okay, in three-dimensional space. So suppose that ABC, which is named by C1, ABC is the curve of intersection of the surface z equal to f of xy and the plane y equal to y naught, which is parallel to the zx plane. I'm showing it in the figure. It is in the next page. Next to next page. Can you see the figure? You see, this is the surface. This one is the surface. This one is the surface, which is represented by z equal to f of xy, and this is the plane in three dimension. This is in three dimension. This is the plane y equal to y0, which is actually parallel to the zx plane. So if this plane intersects this surface z equal to f of xy, you will get a curve. This is the curve. ABC is the curve of intersection of this surface and this plane. Actually, you see, to this curve, if on this curve, if there is a point, fixed point, say x0, y1, x0, y0, if you draw a tangent, if you draw a tangent at this point to this curve, this is the curve of intersection of the surface and this plane. If you draw a tangent here, this here bt is the tangent. This, the slope of this tangent, the slope of this tangent will be equal to the partial differentiation, that means differentiation of this function with respect to x, because here y equal to y naught is a constant. Y naught is a constant. Y naught is constant on the at each point on this plane. So this curve is also, it is a common curve which is on the plane, and all the points on this curve are lying on this plane and also on this surface. And everywhere at this point on this curve y equal to y naught, it is a constant. So there remains only one variable, which is x. So if you differentiate this function with respect to x only, where y is a constant and this constant means y equal to y naught, this differentiation is known as partial differentiation, because in this case you are keeping y constant and you are differentiating this function with respect to x only. Okay, and this partial derivative will actually, it will be equal to the slope of this tangent drawn at this particular point x0 y1 and x0 y1 not to the curve of intersection of this plane and this surface. So this here it was differentiation. Okay, let us go back to the first page. Yes, this was our first page. So you are taking the curve of intersection of the surface z equal to f of xy and the plane y equal to y naught, which is parallel. This plane is parallel to the zx plane. You know, in three dimension, when you take the coordinate system, there are three planes. One plane is xy, other which contains the x-axis and y-axis. The other plane contains y-axis and z-axis, which is known as yz plane. And the third plane is which contains x-axis and z-axis. This is called zx plane. Okay, so the equation of the curve of intersection will be z equal to f of x y naught, because this was the equation of the surface. If you put here y equal to y naught, that means y becomes a constant. So there is only one variable x. So z equal to fx. This is a curve on the zx plane. So z will be actually a function of x only. So if you differentiate this function where y equal to y naught is a constant with respect to x and evaluate the derivative at the point x equal to x naught, it is denoted by this thing, del x of f of x y naught evaluated at the point x equal to x naught. This is called the partial derivative of f of x y evaluated at the point x equal to x naught, y equal to y naught. Because you know in two-dimensional why it gives you the slope, because in two dimension we know that dy by dx when evaluated at x equal to x naught, it represents what? It represents the slope of the tangent drawn to the curve y equal to fx, which is evaluated at x equal to x naught. So in the same way when your surface is in the three dimension, if you take the differentiation, if you perform your differentiation of this function with respect to x, keeping y constant, here y equal to y naught is a constant. So the notation is here, it is del x. When you have a curve in two-dimensional, it is denoted by dy by dx. But whenever you have more than one variable, we denote it by del x. Del x, okay? You are evaluating at x equal to x naught. So actually it is nothing but del z by del x evaluated at x equal to x naught, y equal to y naught. So this derivative is performed, this differentiation is performed with respect to x only, where you have to consider y as a constant. So it will represent this thing, this partial differentiation will represent the slope of the tangent drawn to the curve z equal to f of x y naught. That means at the first state you are taking y as a constant, which is actually, this curve is nothing but the intersection of the surface z equal to f of xy and the plane y equal to y0, which is parallel to the zx plane. Similarly, if you perform this differentiation, that means you are differentiating that particular surface z equal to f of xy with respect to y. With respect to y, you see the partial differentiation is performed with respect to y, where x is a constant. From the very beginning, you are considering x as a constant and you are putting x equal to x naught. And finally, you are putting y equal to y naught. So this will be what? It will represent the slope of the tangent, drawn to the curve at the point x naught y naught, where the curve is the curve of intersection of the surface z equal to f of xy and the plane what? And the plane x equal to x naught, because here from the very beginning x is considered as a constant, x equal to x naught. And this plane x equal to x naught, it is parallel to the yz plane. So you can look it in the second graph. Yes, here this was the original surface and this plane is denoted by x equal to x naught. When this plane intersects this surface, you are getting a curve. You are getting a curve and this point is a particular point on this curve. You see, on this curve, x equal to x naught. At each point on this curve, x equal to x naught is a constant. Only y varies on this curve. And if you differentiate this function z equal to f of xy with respect to x, it will be denoted by this. It will be denoted by this del y of f of x naught y, and it will represent the slope of the tangent bt at the point drawn at x naught y naught. So this is our definition of partial derivative. Here we considered only, in total we considered three variables, x, y and z. And in this representation, z is a function of x and y. So x and y are independent variables and z depends on x and y. So you can perform your partial differentiation of z either with respect to x when y is to be kept constant, or you can perform the differentiation of z with respect to y when x should be treated as a constant. Okay, so this was the physical interpretation actually, and mathematically Mathematically, this is the expression. Partial differentiation is defined like this: del z by del x at x equal to x naught, y equal to y naught. Here it is del x. That means y should be kept as a constant. So you see, this is another notation. If you keep give an index here x, it means it is del f by del x. Del f by del x means del z by del x, and this is the mathematical expression. You see here y is not changing from the very beginning, y equal to y naught, so it is not changing. X is changing, x naught plus del x minus f of x naught y naught divided by del x. So this is a when del x tends to 0. So this is a partial differentiation of this original function when y equal to y naught is kept constant and x is allowed to vary. Similarly, for the partial differentiation of z with respect to y, this is another notation, fy. Fy means it is the partial differentiation of f with respect to y, where x is kept constant. You see, there is no change. This definition comes from the original definition of dy dx. Do you know it? Dy dx means what? Y of what? X plus del x minus y of x. That means f of x naught plus del x minus f of x naught divided by del x. So this definition comes from the original definition of dy by dx. So here x naught is not changing, y naught is changing, y naught plus del y, and here simply y naught, and x naught is not changing. So this is the partial, and del y tends to 0. So this is the partial differentiation of this function f with respect to y when x equal to x naught is kept constant. So if you omit the index, the subscripts, this x naught, y naught, etc., in general, we can write the partial differentiation formula like this: del z by del x, which can also be denoted by zx or fx. This is the subscript. If you give the subscript as x, it means it is a partial differentiation with respect to x. So fx of xy, it will be just like this. Y is not changing, you see. Y is kept constant. X is changing. X plus del x y minus f of xy divided by del x when del x tends to 0. So here y is kept constant and x is allowed to vary. So this will be the partial differentiation of this function with respect to x. And when you perform the partial differentiation with respect to y, then x is kept constant. These are the other two notations, zy. Subscript is y. That means the partial differentiation is to be performed with respect to y, where x is to be considered as a constant. You see, in this formula, x is not changing, y is changing. Here y plus del y, here only y, divided by del y, where del y tends to 0. Okay, so this is our mathematical expression for partial differentiation. Now, when you perform when you do a math, suppose a function is given to you and you are asked to find the partial differentiation with respect to x. So you have to use the notation del x, and just keep it in mind that y should be treated as a constant and x is your variable, and you differentiate with respect to x. That's all. And if you are asked to find the partial derivative with respect to y, then you have to keep it in mind that x is to be treated as a constant. You have to differentiate with respect to y. Okay, so let us now do some math on this partial differentiation. Okay, one thing more, we call this partial derivative with respect to x as the slope of the surface. Actually, it was the slope of the tangent to the surface, but in general, we say it like this. When we perform the derivative with respect to x, we say that it is the slope of the surface z equal to f of xy in the x direction at the point x naught y naught. Similarly, fy x naught y naught, this is the definition, this is the notation, other notation, and it is evaluated at this. It will be the slope of the surface along the y direction. It will be the slope of this surface along the y direction at a particular point x naught y naught. Okay, this is our first math. The first math is done on the physical interpretation. Suppose this is your function f of xy equal to root over 3x plus 2y. You see, there are two variables x and y. Your question is, find the slope of the surface z equal to f of xy in the x direction. In the x direction means you have to perform your partial differentiation with respect to x, keeping y constant, and you have to evaluate this partial derivative at the particular point 2, 5. And in 2, what is it? Find the slope of the surface z equal to f of xy in the y direction. That means here you have to perform del z by del y. And finally, you have to evaluate this partial derivative at this particular point. So let us do the one first, f of xy equal to this. So fx, this is the subscript x. That means you have to perform the partial differentiation with respect to x. You see, this is the notation for partial differentiation. Don't write it like this, d dx. Don't write d dx because this is totally wrong. This is a function of x and y. Either you have to perform the partial differentiation with respect to x or with respect to y. So the notation will be del x of this whole function. Now, how can you do it? You see, this whole thing is under the square root. So you have to consider this whole thing, 3x plus 2y as your x. You have to consider this whole thing as your x. So what is it? Root over x. And what is the derivative of root over x? It is
1 by
1
2.
by, yes. What is it? It is 1 by 2 into root over x. 1 by 2 into root over x. So here the function was root over x. So when you perform the differentiation, it will be 1 by 2 into root over x. Now, this is actually not x. It is 3x plus 2y. So you have to perform the partial differentiation of this inner part, 3x plus 2y, with respect to x. So that's why you have to multiply this thing by what? Del x of 3x plus 2y. Now this is an addition of these two, so it will be actually del x of 3x plus del x of 2y. Y is to be treated as a constant, so it will be only 3. It will be only 3 because del x of 3x is 3 and this y is to be treated as a constant. So it gives you only 3. So it is 3 by 2 into this. Now you just put down the value of x and y. X is 2 and y is 5. X is 2, 3, 6 and y is 5. So ultimately the result is 3 by 8. So z is increasing. This is the partial derivative of f with respect to x. So f means z. So z is increasing at a rate of 3 by 8 units per unit increase in x because it was the change with respect to x, change of f or z with respect to x. Now, number 2, here you have to perform, it is in y direction, so you have to perform the differentiation with respect to y. So del y of this. So here it is the differentiation with respect to y. So you have to consider the inner part under the square root, whatever it is, you have to consider it as y. That means it is root over y. So derivative of root over y, it is 1 by 2 into root over y. So 1 by 2 into root over y, but this thing was not only y, it is 3x plus 2y. So according to the chain rule, you have to multiply it by what? Derivative of this, 3x plus 2y with respect to y. So del y of this. And here x is to be treated as a constant. So this term gives you 0. There is a plus sign. So del y of this plus del y of this. So this will be 0. And when it is del y of simply y, you can write, in that case, you can write dy of 2y. It will give you simply 2. So 2 by 2 cancel out 1 over this. Now you just put down the value of x and y. X is 2, y is 5. And this is your value, 1 over 4. Okay. Okay, let us now go to next math. This is your function. Z equal to x square y to the power 4 divided by root over x plus y. Find del z by del x and del z by del y. So at first you have to differentiate it with respect to x and then we have to differentiate it with respect to y. In this case, y to be treated as a constant, here x to be treated as a constant. So at first let us find del z by del x. You see, this is a quotient form. This is in quotient form, so you have to apply the u by v rule. U by v rule. So in the denominator, you have to write what? Root over x plus y whole square. Whatever it is, root over x plus y whole square. So the square root and the power to cancel, it will be simply x plus y. And what will be it in the upper part? The lower part into del x of the upper part. You see, the lower part is root over x plus y, lower part into del x of the upper part minus the upper part into del x of the lower part. So this is a product of two functions, x square y to the power 4. So y to the power 4, this factor should, this is a factor now, not a term, it is a factor. This factor should be treated as a constant. So ultimately you have to differentiate it only with respect to x, this x square. So it will be y to the power 4 into 2x. So I have written it here, 2x into y to the power 4 and into this thing. Then minus x square y to the power 4, and what is the derivative of this? So here it is the differentiation with respect to x. So you have to consider it like this, root over x, and the derivative of root over x is 1 by 2 into root over x. Your root over x means root over x plus y, and then del x of this inner part, x plus y, because you have treated this x plus y as a single variable x. So you have to multiply it by the derivative of x plus y. It gives you simply 1 because y is constant. This term gives you 0 and this term gives you 1. So it will be simply this. Now, in the next step, what we have done, we have taken the LCM. This gives you only 1. So the LCM is root over x plus y. So in the next term, it will be x plus y into root over x plus y. That means x plus y whole to the power 3 by 2. And you have to multiply this into this, so it will be there is a 2 here, so 2 into 2 xy to the power 4 into root over x plus y into root over x plus y, so ultimately x plus y, and here there will be only x square y to the power 4. Now you perform this product, you see, ultimately the result will be this. It will be 4x square y to the power 4, and there is x square y to the power 4. So ultimately 3x square y to the power 4. And from this term, it will be 4x y to the power 5. Okay, so this is the value of del z by del x. Now del z by del y. So here we have to perform this differentiation with respect to y. So again we have to use the u by v formula. In the denominator it will be root over x plus y whole square. Root over x plus y whole square. Then in the upper part, the lower part, this was the lower part, root over x plus y, lower part into del y. It is with respect to y. So del y del y of x square y to the power 4 minus the upper part. This was the upper part into del y of the lower part, root over x plus y. So this will give you xy is constant now. It is a constant coefficient. And derivative of y to the power 4 is 4y cube. So it will be simply 4x square y cube. Yes. 4x square y cube into root over x plus y. And here you have to consider it as root over y, and del y of root over y is 1 by 2 into root over y. This is your 1 by 2 into root over y, where this x plus y was considered as a single variable y. So you have to multiply it by the derivative of this x plus y with respect to y. So here again this x will give you 0 because this x to be treated as a constant, plus ddy of this y, which will give you 1. So again you perform this, this factor is giving you only 1. So again you perform this LCM. LCM will be 2 into, I think there should be a 2 here. It will be 2 into x plus y because your LCM, in the upper part, your LCM will be 2 into root over x plus y. So these two should come here. 2 into x plus y whole to the power 1 plus half, that means 3 by 2. So there should be a 2 here. I think there was the same mistake here. These two, yes, these two should be here. And sorry, when you take the LCM is 2 into root over x plus y, and you are taking this whole thing to the lower part. So there should be a 2 here. Please do this correction. Are you listening to me?
Yes, miss.
Okay, so
Yes,
please
miss.
write a 2 here. This is a mistake here. Write a 2 here, so there should be a 2 here. Again, in this expression, these two should come here. 2 into this. And here 2 into 4 is 8, 8 x square y cube, and this root over into this root over x plus y, and here it will be simply x square y to the power 4. After doing the algebra, this gives you the result. Okay, now the next math. Find fx xy. That means what is it? It is actually del f by del x. It is actually the partial derivative of f with respect to x. And here it is the partial derivative of f with respect to y, where there are two functions. In one, it is this, f of xy equal to y to the power minus 3 by 2 into tan inverse x by y. And in the second, f of xy equal to x cube into e to the power minus y plus y to the power 4 sec root over x. So at first we do the number 1. This is our function. So we are finding what? Fx. Fx means del f by del x. So del f by del x means del x of f. F means this. That means you have to differentiate this whole thing partially with respect to x. So here you see there are two factors. One factor is this y to the power minus 3 by 2, and the second factor is tan inverse x by y. Here this factor, the first factor, does not contain any x. So this is our constant because our derivative is with respect to x. So this y to the power minus 3 by 2 should be treated as a constant factor. So you can take it outside this derivative, y to the power minus 3 by 2 into del x of this tan inverse. Now, this x by y should be treated as a single variable x because our partial derivative is with respect to x. So just consider this x by y as your x. So what is the derivative of tan inverse x? You know it.
1 by 1 plus x square.
Right. So 1 by 1 plus x square. Now, what is your x? Your x means x by y. So it will be 1 over 1 plus x square by y square. But this is not simply x. It is actually x by y. So you have to differentiate this x by y partially again with respect to x and then multiply with this. So it will be, should be multiplied by del x of x by y. So here, if you do this algebra, y square is the LCM, it will go up y square, and in the lower part it will be x square plus y square. And here, what is the partial derivative of this? You see here 1 over y is a constant factor. So del x of x is 1. So if you take this 1 over y outside, it will be 1 over y into del x of x, which is simply 1. So the result will be just 1 over y. And this y and this y square cancel out. There will be a y here. So this y into y to the power minus 3 by 2. That means the power to this y will be minus 3 by 2 plus 1, and it will be simply minus half. So I have written the result here. In the upper part, it is y to the power minus half, and in the lower part, x square plus y square. So if you take it to the lower side, it will be y to the power half, and y to the power half means root over y. So this is the result of fx, del f by del x. Now we find del y of f. Fy means del y of f. This is our f. So here it is a partial differentiation with respect to y. And here you have two factors, y to the power minus 3 by 2 into tan inverse this. Here both the factors contains y. Both the factors contain y. So it should be like this. This factor into del y of the second factor plus the second factor into del y of the first factor. It is actually of the form u into v. Just apply the product rule for uv. So y to the power minus 3 by 2 into del y of this plus tan inverse x by y into del y of this. Here, okay, here you can use, I think this is a mistake here, not a big mistake, but still it is a mistake. This, there is no x here, it is only y. So you could have written it like d dy, because it is not a partial differentiation, it is a total differentiation, because this factor does not contain, this part does not contain any x. So we could have written like this, d dy of y to the power minus 3 by 2. Anyway, so y to the power minus 3 by 2, this should be performed, the differentiation should be performed with respect to y. So this is x over y. So this whole thing should be treated as y, because our differentiation is with respect to y. So tan inverse y, what will it will be? It will be 1 by 1 plus y square. And y means this, x by y. So it should be 1 over 1 plus x square by y square. And this x by y should be again partially differentiated with respect to y and then multiply to this. So it should be multiplied with what? Del y of x over y. And here tan inverse x by y, d dy of y to the power minus 3 by 2. So it will be what? Minus 3 by 2 into y to the power minus 3 by 2 minus 1. That means it should be, the sign will be minus now, 3 by 2 y to the power minus 5 by 2 into this. And here del y of x over y, x by y. So x is a constant, you can take this x outside of this partial derivative, and del y of 1 over y, it is nothing but minus 1 by y square. So ultimately it will be minus x by y square. So here this y square and this y square, this you see after doing the algebra, this y square will go up, and in the denominator it will be x square plus y square, and this y square and this y square will cancel out. So there will remain only what? This term will be minus x into y to the power minus 3 by 2 divided by x square plus y square, and the same thing here. Okay, so this was the partial derivative of the function with respect to y. Now for the second one, second function. So here we have two terms. So del x, at first you have to find the del x of f. So del x of this whole thing, at first we separate the two terms u plus v. Del x of u plus del x of v. Okay, here you are performing that differentiation with respect to x. So y should be treated constant. That means this e to the power minus y is a constant factor. So this constant factor into del x of x cube. And here in this case, y to the power 4 is a constant factor, because you are performing the differentiation with respect to x. So y to the power 4 into del x of sec root over x. Here again we could have used d dx, because there is no y here. So it would be better if you write it like this, d dx of sec root over x. Now, e to the power minus y, here also you could have written d dx of x cube. D dx of x cube means 3x square. So 3x square e to the power minus y plus y to the power 4. Now it is not simply sec x, it is sec root over x. So this whole root over x should be considered as x. So what is the derivative of sec x? Derivative of sec x is what? You know it. It is sec x tan x. No, not minus, no minus sign. Minus sign comes when your function is cosec x. D dx of cosec x is minus cosec x cot x. But d dx of sec x is plus sec x tan x. So this sign will not change. Y to the power 4 into sec x tan x. Your x means root over x. So you have to write root over x here. But this is not simply x, it is root over x. So you have to perform the differentiation again for this root over x. So I think we should have written it d dx. Here also d dx. Here also d dx, because there is no
major problem, like
it is not a major problem, but it is a problem. It is not a major mistake, but it is a mistake, because there is no y. we could have written it like d dx, d dx of
এই
x cube.
এই প্রবলেমের জন্য কি মার্ক কাটা যাবে?
Um, I'm not sure, but please try to write it properly. Huh? The properly, if you want write to properly, it should be like this: d dx of x cube. Here d dx of sec root over x. Here also d dx of root over x. Now, what is the d dx of root over x? It should be 1 by 2 into root over x. So it should be y to the power 4 divided by 2 into root over x. Sec root x, tan root x. Now we will find the derivative, partial derivative with respect to y. With respect to y. So you see, I have done the same thing here. I could have written here d dy because there is no x. So the del y of the first function plus del y of the second function. And del y of the first function will be x cube can be treated as a constant factor, so it is taken outside. So it should be d dy of e to the power minus y plus. This factor does not contain any y. So sec root over x into d dy, it should be d dy of y to the power 4. So here comes, what is the d dy of e to the power minus y? It should be minus e to the power minus y. So there should be a minus sign here, minus x cube into e to the power minus y. Here, this should be there, sec root over x, and here it will be 4y cube. Okay, so that's all. This is the result. Now, there is a function, there may be function in which there are 3 variables. Here are 3 variables. So far we have done the math. In all of these maths, there were 2 variables, independent. There were 2 independent variables. F of xy equal to this. F of xy equal to this. There were only 2 variables, x and y. In the previous problems also, there was only 2 variables, x and y. But here now, there are functions in which more than 2 variables. X, y, z. So all of these 3 are independent variables. F of x, y, z, you see, this function contains 3 variables, x, y, and z. And so you can find what? Fx, that means del f by del x, where y and z, both of them should be treated as constants. When you find this fy means del f by del y. So x and z should be treated as a constant. When you find fz, that means it is del f by del z. So in this case, x and y should be treated as a constant. So these are the functions here. Okay, let us take the first function. So this is your function fx. It means del f by del x. So del x of this whole thing. So in this function, you see, z is a factor, and it does not, this factor, there are actually 2 factors. One is z, and the other is ln of this whole thing. This whole thing is the argument of ln. So z, this factor does not contain any x. So you can take it, this z, outside the derivative. So it should be z into what? Z into del x of this ln of this. And ln of this, and your partial derivative is with respect to x. So this whole thing should be treated as x. So it will be ln of x means what? 1 over x, 1 over x, and your x is this whole thing. So it should be 1 over this whole thing. But this is not simply x. So you have to differentiate this whole thing again with respect to, partially with respect to x, and then multiply the result with it. So ultimately it will be z into 1 over x, 1 over x means this, into del x of this whole thing. Okay, so again, it is a product of what? There are three functions here, x cube, y, and cos z. 3 functions are there. But here you have to perform your differentiation with respect to x only. So which are constants here? Which are constant factors?
Z and y.
Yes, y and z are constant. So this y and this cos z can be taken outside. Y and cos z, they should be treated as constant factors, and you have to perform the derivative differentiation only on this x cube. So it will be 3x squared. 3x square into y cos z. Now you can cancel this y and y from the upper and the lower part, cos z and cos z. So there remains only what? One again x square and x cube, so there remains an x in the lower side, so it will be ultimately 3z divided by x. So this is the result for fx. Now we perform the differentiation with respect to y partially. So del f by del y, it means del y of this whole function z into ln of this. So again z, this factor z does not contain any y, so you can take this z outside the differentiation. So z is taken here, ln of this. So ln of this whole thing should be treated as y because our differentiation is with respect to y. So it will be 1 over y. 1 over y means 1 over this whole thing into del y of this thing, because we have treated this whole thing as y, but it is not y. Because this is not simply y, it is x cube y into cos z. So this whole thing should be differentiated partially with respect to y. So again, you have to multiply this whole thing by what? Del y of this. So here, which are constants? Please tell me, which are constants? Which are constants?
যেহেতু y রাখতেছি তার মানে x and z
X
constant.
cube, yes, this x cube is a constant factor and cos z will be constant factor. So del y of y, it is only 1. That means it will be, after performing this partial differentiation, it will be simply x cube into cos z. X cube into cos z, because del y of y is 1. So this x cube and x cube cancel, cos z cancel, the result is z over y. Now let us perform the partial differentiation with respect to z. So fz means del f by del z. So del z of this f, this was our f. Now you see the factors, both of them contain z. Z into ln of this. Here it is only z. So you have to perform it using the product rule, uv. So your u is z and v is ln of this. So at first, if you keep this ln of this thing constant and del z of z is 1, so it will be 1 into ln of this. 1 into, for this z 1, 1 into ln of this plus z into del z of ln of this. So this term will be there overall in all the steps, and here z into del z of this. So again, ln of this whole thing should be treated as your z. So ln z gives you 1 over z. That means z by this x cube y into cos of z, and this whole thing should be differentiated partially again with respect to z and multiply it with this thing. So del z of this. So in this case, which are constant factors? X cube y. X cube y will be constant factors. And what is the derivative of cos z with respect to z?
This minus sign z হবে না?
Minus sin z, right, minus sin z. So it will be what? Z by x, this z divided by this whole thing will be there. And for this partial derivative, it will be minus x cube y sin z. Minus sign is there, minus x cube y sin z. X cube y cancel out. So this is your result. Okay, now the second function. The second function, it is y to the power minus 3 by 2 into sec xz by y. So at first we find the partial derivative with respect to x, del x of this whole thing. So you see, actually it was a product of two functions. And you see this factor, this function does not contain any x. Our partial derivative is with respect to x. So you can take this factor outside the derivative. So y to the power minus 3 by 2 into del x of this thing. So here, sec of something, this something should be treated as single x, because our partial derivative is with respect to x. So if it is sec x, it gives you sec x tan x. So this y to the power minus 3 by 2 sec x into tan x. But this is not simply x, it is xz by y. So you have to multiply by what? Partial derivative with respect to x of this, del x of xz by y. So here this whole thing should remain there, and here it is a partial differentiation with respect to x. So this z over y can be taken as a constant factor outside the differentiation. So z over y into, okay, here it is written properly. It should be written properly like this: z over y into d dx of x, and d dx of x means it is simply 1. So ultimately this part gives you 1, so it will be z into what? Y to the power, this z into y to the power minus 3 by 2 minus 1. So ultimately it will be minus 5 by 2 and the remaining thing. Okay, now we find the partial derivative with respect to y. So here del y of this whole thing, now you see these two factors, both of them contain y. It is y to the power minus 3 by 2, and this sec also contains this y. So it will be what? Derivative of the first function into the second function. We didn't touch this part here in the first term. We have found the derivative of this. It will be minus 3 by 2 into y to the power minus 5 by 2 sec of this plus now y to the power minus 3 by 2 into del y of this sec. Okay, so this will be there, this first term will be there overall in all the steps, and here y to the power minus 3 by 2 into del y of this. So this xz by y should be treated as a single y. So what is the derivative of sec y with respect to y? It will be sec y tan y. So this is your sec y tan y, but it is not single y, so you have to multiply this whole thing by what? D dy del y of this xz by y. Yes, del y of this xz by y. So in the next step, it should be y to the power minus 3 by 2 sec tan etc. And here z, x and z are constant. So let us take these two factors xz outside. So it should be d dy of 1 over y. And d dy of 1 over y, it is minus 1 over y squared. So let us take it here, and y to the power minus 3 by 2 minus 2, it should be minus 7 by 2. So xz into y to the power minus 7 by 2 into this. Okay, I didn't do in details the derivative of f with respect to z. The result is given to you. Please do it by yourself. Please do it by yourself. Now, the third function, it is tan inverse 1 by x y square z to the power 4. There is only one function. There is only one function, but this function contains all the variables x, y, and z. So derivative of it with respect to x, it will be del x of what? Tan inverse this. So it is a derivative, partial derivative with respect to x. So this argument, this whole thing should be treated as x. And you know d dx of tan inverse x is 1 by 1 plus x squared. So it is 1 by 1 plus your x is this, 1 over this. That means it will be 1 over x square y to the power 4 z to the power 8 into. This whole thing is not simply x. So you have to multiply this thing with what? Del x of this. The part which you have treated as x. So del x of this whole thing. Now you do this algebra, your LCM will be x square y to the power 4 z to the power 8. It goes upper side, and in the lower part it will be x square y to the power 4 z to the power 8 plus 1 into what? Here 1 over y square z to the power 4. This is constant. So I have taken it outside, 1 over y square z to the power 4. So there remains what? Okay, I think this is, okay, no. It's okay. Del x of this. This is okay. So one over,
ফর্মুলাটা বসাই দিয়েছেন মানে রেজাল্টটা বসাই দিয়েছেন
okay, yes. Yes, I have taken this 1 over y square z to the power 4 constant as a constant outside because it is partial derivative with respect to x. So there will remain what? This thing into del x of 1 over x. And del x of 1 over x means what? Minus 1 over x square. So this x square and x square cancel out. 1 y square cancel out, 1 z to the power 4 cancel out. Ultimately, this is your result. Now we perform the differentiation with respect to y. So again, this is tan inverse. This whole thing should be treated as y. So tan inverse y with respect to y, it will be 1 over 1 plus y squared. The same thing will come here. After doing the algebra, this will be in the upper part, this will be in the lower part. And now which factors is constant? X and z to the power 4. So 1 over x z to the power 4 is a constant. It is taken outside. There remains what? D dy of 1 over y squared. D dy of 1 over y square, it means what? Actually, the power of y is minus 2. So it should be minus 2 into y to the power minus 3. That means it will be minus 2 by y cube. Just perform d dy of 1 over y square. 1 over y square means y to the power minus 2. That means it will be minus 2 into y to the power minus 3. So ultimately minus 2 by y cube. So now 1x cancel out, 1z to the power 4 cancel out, and 1y cube cancel out. So ultimately it will be minus 2x y into z to the power 4 divided by this. Okay, there is one derivative remaining with respect to z. So again, the same thing, you treat this whole thing as your z. So 1 by 1 plus z square. After doing the algebra, you will get this. Now del z into del z of this. So which factor is constant? 1 over xy square. 1 over xy square is constant. So you have to perform the differentiation d dz of 1 over z to the power 4. 1 over z to the power 4 means z to the power minus 4. So it will be minus 4 into z to the power minus 5. That means minus 4 by z to the power 5. So after cancelling the common factors, you are getting this result. Okay, this is another function, different function. Z equal to x to the power 4 into ln of this. Find zx and zy. Zx and zy means, okay, you see this is only a function of two variables x and y. I think you can go, the math is done here. I think you can go through it by yourself because the right side is only a function of x and y. I'm not going through the details of it. You please go through it by yourself. Okay. This is different type. Here again, this is a function of x and y only, but here after finding the partial derivatives, you have to evaluate the partial derivatives at the point 2, 1. At first find del f by del x, then put x equal to 2, y equal to 1, and then you find del f by del y at the point x equal to 2, y equal to 1. So this is your function. Del x of f, so del x of this whole thing. So you see, actually there are three factors. One is x square, the second factor is y, and the third factor is e to the power xy. You see the second factor y, this should be treated as a constant because you are performing the partial differentiation with respect to x. So it should be what? Y into, you can take this y outside the differentiation. Y into del x of x square into e to the power xy. So y into this whole thing, you see this is a product of two functions, x square and e to the power xy. So at first I keep this x square fixed. So u into del x of v plus v into d dx of u. You see, x square into del x of, here I am using del x because this factor contains x and y both. And here, when you take this e to the power xy outside, this factor xy does not contain any y. That's why I have written here d dx of x square, because there is no y here. Okay, so this y remains outside throughout all the steps. So x square into del x of this. So this power contains both x and y. So this power, the whole power should be treated as x. So e to the power x gives you e to the power x. E to the power xy, and you have to differentiate this xy. This xy was treated as single x. So it should be multiplied by del x of xy. Del x of xy, and here d dx of x squared is 2x, so 2x into e to the power xy. And what will be the derivative of xy? This y should be treated as a constant. So it should be y into d dx of x. That means just 1. So it will be y into what? X squared into y. Yes, x squared into y. This y is coming here. X squared into y into e to the power xy. And here 2x into e to the power xy. Now you have to find the value at x equal to 2, y equal to 1. So you just put x equal to 2 here and y equal to 1. So it will be 1 into 2 squared into 1 into e to the power 2 into 1. And here 2 into 2 into e to the power 2 into 1. So ultimately you are getting what? 4 into e to the power 2 plus 4 into e to the power 2. That means 8 e to the power 2. Okay, let us now find the partial derivative with respect to y. With respect to y, here x square can be treated as a constant factor because this factor x square does not contain any y. So let us take this x square outside the partial derivative. So it will be x square into del y of y into e to the power xy. So let us keep this x square outside this third bracket. So first function into derivative of the second function. Y into del y of e to the power xy plus e to the power xy into d dy of y. There was no x, that's why I have written here d dy. So here you have to treat this x into y as a single y because the derivative is partially with respect to y. So e to the power y after differentiation gives you e to the power y. E to the power y means e to the power xy. And you have to multiply it by what? Del y of xy. Del y of xy. So here d dy of y is 1, so 1 into this, and here x should be treated as a constant, x into d dy of y, which is 1. So it will be simply x into this y into e to the power xy plus e to the power xy. Now to find fy at 2, 1, just put x equal to 2, y equal to 1. So 2 square into 2 into 1 into e to the power 2 into 1 plus e to the power 2 into 1. So outside it is 4 and here 2 plus 3. 2 plus 1, 3, it is square. So 12 is square. Okay. There is another math. Here, how many variables are there? There are 4 variables. You see, u is a function. U is a function of w, x, y, and z. There are 4 variables, and this is a function x into y to the power w into sine square z. So you see x, y, w, z. All the 4 variables are present here. Your question is find ux at this point, uy at this point. The point is same. 0, 0, 1 pi, 0, 0, 1 pi, 0, 0, 1 pi. Your question is find these 3 derivatives. Del u by del x, where y and z should be treated as a constant, del u by del y, where x and, okay, the remaining 3 variables. When you find del u by del x, w, y, and z are constant. When you find del u by del y, w, x, and z are constant. When you find uw, then x, y, and z are constant. So all these derivatives should be treated at this point, 0, 0, 1 pi. Okay. This is your function. At first we find ux. Ux means del x of this whole function. So you see this whole thing is a constant factor. E to the power yw. There is no x. Sine square z. There is no x. So e to the power yw sine square z into d dx of x. D dx of x is just 1. So this will be the result. E to the power yw into sine square z. Now you just put down the value of y, w, and z. So this is w, this is for w, x, y, z. X is 0, y is 1. Y is 1, and what is w? W is 0. This is z, z is pi, okay? So sine pi is 0, so ultimately the result is 0. Now here, del y of this, del y of this. So x and sine square z can be treated as a constant factor. X sine square z into del y of e to the power yw. So here this y into w should be treated as simply y. So e to the power y after differentiation gives you e to the power y. X sine square z e to the power y means e to the power yw. Then you have to multiply it by what? Del y of yw. Del y of yw should give you simply w, because it will be w into ddy of y. Ddy of y is 1. So x into w into sine square z into e to the power yw. Now just put down the values. Here the first one was for w. So w equal to 0, y equal to 1, x equal to 0, and z equal to pi. Ultimately this is also 0. Now the third one, here you have to perform it with respect to w. So here x and sine square z are constant. X into sine square z, this is constant, so del w of e to the power yw. Just like the previous one, consider it as w. So del w of e to the power w means e to the power w. In place of w, you have yw, so it should be multiplied by what? Del w of yw. So y is a constant factor and ddw of w is 1. So it should be multiplied, the whole thing should be multiplied by y. So x, y square, sine square z this. The first one was for w, the second one x. So w equal to 0, x equal to 0, y equal to 1, z equal to pi. Ultimately this is 0. Ultimately this is 0. I think there is only one math remaining here. If w equal to root over x square plus y square by z square, show that x into del w by del x plus y into del w by del y plus z into del w by del z equal to w. So this is your function. So at first, this is a function which is a function of x, y, z. So at first we find this one, del w by del x. So del x of this whole thing. So you see, you know it is a partial differentiation with respect to x. So this whole thing should be considered as root over x. As root over x. And what is the derivative of root over x? It will be half into x to the power minus half. Half into x to the power minus half. So half into this whole thing is your x to the power minus half, but this thing should be differentiated partially again with respect to x and then multiply here. So this should be multiplied by what? Del x of this whole thing. And you see there are three terms. Y square is a constant, z square is a constant. When you perform the partial differentiation with respect to x, this term will give you 0, this term will give you 0, and the first term will give you 2x, just 2x. So it will be this half into, it means 1 by root over, to the power minus half means 1 over root over this. So 2x, and 2 to cancel out, so it is x by root over this. Similarly, you can find the remaining partial derivatives. Here del y of this, so you have to consider it as root over y. So root over y, when differentiated with respect to y, it should be half into this whole thing, whole to the power minus half. And it means 1 by 2 into 1 by root over this. And here you have to differentiate this x square plus y square by plus z square with respect to y. So this x square will give you 0, this z square will give you 0, and this y square will give you 2y. So 2 to cancel out, it will be y by this. Similarly, when you find del w by del z, the result will be z by this. So now let us find the value of this. So x into del w by del x. What was the value of del w by del x? It was x by this. So x into this, it means x squared by this. And the next term was y into del w by del y. So y into this, that means y squared by this. The third term was w into del w by del z. So sorry, z into del w by del z. So it should be z into this, that means z squared by this. So the result value of these three terms should be like this. So LCM is same. So the upper part should be just x square plus y square plus z square, and the power 1 power half can be cancelled. So you will have simply in the upper part root over x square plus y square plus z square, and this is nothing but the original function w. So this thing should be equal to W. So it has been proved here. And it was the last math. You see, the file is already uploaded. Have you seen it? This file is already uploaded, so you can go through it. So our time is also over. Let us end our class here. I will upload the recorded file later on when I get it. Okay. Thank you so much.
Miss
This is the end. Oh yes, I totally forgot. I totally forgot. Do we have time?
Last minute, miss.
Sorry, I think this. So